Hello guys, welcome back to the project 3 where we are going to learn about gradient descent and logistic regression model. So let's see the problem statement. So the problem statement says we have to find gradient descent. So we have to make gradient descent and record the loss at each iteration. So okay, I'll explain gradient descent. So what is gradient descent? So gradient descent is basically used to minimize the loss function of a particular model. So every model would have a bit of loss function, whatever loss. So you have to reduce it. Lower the loss, higher the accuracy of the model, or more good is the model. So how do we do this? We do this by adjusting the weights. We have something called weights. So we do this by adjusting the weights so that we can reduce the difference between the actual values and predicted values. So this involves a few steps. I'll tell the steps. So first thing is basically we find the loss function. We basically give weights, the learning rate and all, and then we set number of iterations, that is epochs, and then we give the loss function. Once we give the loss function, we get the loss, and then we have to find out the gradient, the weight gradient and bias gradient. Then using that gradient, we have to update the weights and bias, and then see what is the loss. So this keeps on iterating till the number of epochs which I give. So this is the entire overview of the problem. So yeah, the task is to add a bias, implement logistic function. We are using the sigmoid function, by the way. So then compute the binary cross entropy loss, that is loss, and then update the weights using gradient descent, track and return to each epoch. Okay, so understood now. We'll go through the code now. The first line says, as usually, import np numpy is np, and then we're defining a function again which says train log regression, logistic regression. Here we have x and y. So this is again two arrays. Then we have the learning rate which would be given, and then epochs. Epochs is number of times you're going to iterate this. So then we have the basically we have the n samples and number of features and samples of the model of the array. So basically we have the number of samples and features of the array, and setting bias as 0 and weights as n features. We are giving the weights as zeros. So then we have a string for loss, and now what we're doing is we are going through number of epochs which will be given in the function. Number of epochs, everything will be calculating z. So what is z? Z is basically the combination of weight and bias. This is used in every model where we have to find the logistic regression and all. This is how do we find it? It is basically weights into weight 1 into weight 2 plus bias, weight 1 and weight 2 into weight 3 plus bias, like that. So then to prevent overflow, because sometimes sigmoid, if it is a very huge negative function, it can overflow. So to avoid overflow, we are using this. And now we are using the sigmoid function. So basically, what is sigmoid function? Sigmoid function reduces anything and it scales it down in between 0 and 1, 0 and 1, 0 and 1. So this is what sigmoid do. It is basically either 0 from 0 to 1. It is not above that or below that. So this is sigmoid function. Now we calculate loss. So loss, we first calculate the epsilon and then the loss in the predictions. So in this, if predictions is either 0 or 1, then we can't find log 0, that becomes undefined. So we are basically removing that as well. And now we're calculating the loss function. So this is the formula for calculating loss function for any model. So then we are appending it and keeping it to 4 decimal places. Now we are doing the gradient descent. Here backward propagation. So it keeps going backward every time, checking backward every time. So at the end we have to get the proper thing. Now we are calculating the gradient. Like I said, after calculating loss function, we have to find out the gradients. So gradient of weight, and this is gradient of bias. So this is the sum of error for bias, and this is the weight. Now we are updating the weights. Basically weight equal to weight minus learning rate times gradient of weight, and then again bias equal to bias minus learning rate times bias, gradient of bias. So then we are finding the final weights by again making it weight 1 into weight 2 plus bias. So this is the final weight. Then we are returning the final weight and losses. And one more thing is we are storing losses as well. This is the problem. And in this weights and losses, we are giving it to the input would be to the arrays are given here, and learning rate we're setting is 0.01, and number of epochs is 20, that 20 times in loops this keeps going, printing. Let me run and show this to you. Okay, so when you run this, this is the value of weight. So it's the value of weight, and then we have loss for each one. We have one loss for each epoch. So we have here we have total of 20 losses, and then this is the weight. So that's it for this video. I hope you guys understood what gradient descent is, how it works. If you can go through this concept, if you've not, in CodeChef platform, if you want to practice this and be more confident and learn more about this, then you can check out CodeChef platform. So yeah, that's it for this video. Thank you. Thank you.